All right, so let's work a real world problem. This is kind of interesting to me. I do this every year. What we're going to do is we're going to talk about what's called Snell's law. Now, Snell's law actually talks about how light bends through different mediums. So have you ever noticed, like, whenever you're standing in water, if you're looking in water, something looks closer to you than what it actually is, or you kind of see how light kind of distorts going through different objects. Snell's law actually gives us a way to actually know what's going on. Snell's law is this. We're going to do sine of, I'm going to call theta sub 1 over sine of theta sub 2 equals v sub 1 over v sub 2. Now, my v sub 1 over v sub 2 is actually called the index of refraction. And different mediums have different index of refraction. These v's are the velocities, so it's going to be unitless because the units are going to cancel on your velocities, such as light travels at a different speed through air than it travels through water. So you have a difference in velocities as light's going through water, and then as that light enters the air and enters the water, it's going to slow down and go to a different velocity. And that's what this actually is. Now, theta sub 1 is what we call our angle of incidence. And I'm going to draw a picture to help explain this. Angle of incidence. See, I spelled it here. I think I even spelled it wrong on my paper. Whatever, my angle of incidence. And theta sub 2 is my angle of refraction. Okay, so that's how we define variables. Well, here's what we have my medium right here. This is my medium. It could be anything. We have, say, a light coming in this way, and then it bends this way. If I picture a vertical line right at that point of bend, this angle right here, we call that my angle of incidence. Something like that. And then this angle right here, we call this my angle of refraction. All right, so once you know the setup and how everything is defined, we actually have some pretty interesting type of problems. You'll see in problems I assign you, I actually give you a table of the index of refractions for different mediums. I'm going to ask you to find maybe the angle of incidence or the angle of refraction from there. So let's look at an example of how to actually use all of this in a problem. All right, so let's say we have some water right here. This is water. And then coming down this way, this is all water. We have light passing through air in the water, and it bends. And then we know from Snell's law that right here, this is my theta sub 1, this is my angle of incidence. And then right here is my theta sub 2, and this is my angle of refraction. Okay. Now, what we need to know is the index of refraction. The index of refraction for water is 1.33. So my index of refraction, and you would have a table of this. I'm not going to ask you to actually try to find it. The index of refraction is 1.33 for water. All right. And then I'm going to tell you that the light is coming in, so this angle right here is coming in at 80 degrees. So my theta sub 1, or my angle of incidence, is 80 degrees. I want to ask you to find what is the angle of refraction. Well, we're going to use the Snell's law. We're going to do sine of 80 degrees over sine of, I'm just going to call that theta sub 2, because that's what I'm looking for, equals, well, my index of refraction, which is 1.33. Well, I'm trying to solve for sine of theta sub 2. So because my unknown's here, I can just swap these, and I can say sine of theta sub 2 equals sine of 80 degrees over 1.33. Now I did a couple things here. I swapped these and then I used the property of equality by flipping it around because I like having my unknown on the left side. That's just my preference. Here I take the arc sine and I'm going to say theta sub 2 equals arc sine of 80 degrees over 1.33. So from there, you just put it in your calculator. This is a degree, so it needs to be in degree mode. These are always going to be in degrees because it's a bend. It's going to be how much did it bend. It's not an actual distance, so it's not going to be a radian. When you throw this in, we find that theta sub 2, when you throw it in the calculator, is 47.77 degrees. And that's all you need to know because all you need is just that one positive angle. There's not going to be, like what we've been solving, 3, 4, 5, 6 different angles. Now, you could be... Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.